So for our next content, we will be discussing about the Newton-Rhapson method. Ang maganda kay Newton-Rhapson method is ito yung method na gamit ng calculus nyo sa paghanap ng roots ng single variable equations. Diba? So, sabihin, pag alam nyo na kung paano to gawin at na-program nyo na siya, so parang gumawa na kayo ng sarili nyong shift solve function. Okay? Now, from the visualization, so ganito siya nag-work. Okay? Ina-approximate niya yung graph ng f of x by using tangents. Okay? So using an approximate value of x naught, initial guess, so hinahanap natin yung tangent line at y is equal to f of x naught. Okay? So, yung tangent line na yun, i-extend natin yan, and kung ano yung intercept niya sa x-axis, yun yung gagawin nating improved guess. So, tulad nga ng sabi dito, ina-approximate niya yung graph using suitable tangents. Okay? And kung mapansin mo, dito sa graph na ito, pag ginamit mo si x1 as the next guess, yung intersection ng tangent line sa x-axis is papalapit ng papalapit doon sa root. So, yun yung strategy na ginagawa ni Newton-Rhapson method. Okay? So, ayan. So, essentially, si line na ito is just equal to the slope. So, yung slope ng line na ito is equal to f of x naught over x naught minus x1. Okay? Now, if we isolate x1, para mahanap natin si x1, ito lang siya. x1 is equal to x naught minus f of x naught over f prime x naught. So, itong equation na to, ito yung panggagalingan ng general equation for Newton-Rhapson method. So, in general, to solve for the improved solution, ang gamit natin is the old solution minus f evaluated at the old solution or previous solution over f prime evaluated at the previous solution. So, again, ganito siya graphically. Okay? So, ito ay GIF. So, nag-start dito. Tangent line, ito na yung next guess. Tangent line, ito na yung next guess. Dito, tangent line, ito na yung next guess. Tangent line. So, pansin nyo, sobrang lapit na natin doon sa root nung equation. So, ito ay function tangent. Hindi ko lang kung anong language yan. So, hayaan ko lang siya mag-play for the last time. Yan. Okay? So, ayan. This slide shows lang a algorithm. So, here, yung error is solved as yan, tawag dito, absolute error. Pero pwede siyang maging relative error. So, you can read this on your own. So, try natin siya doon sa previous equation natin. So, we have f of x equal to x squared minus 3x plus 1. So, we derive the derivative, which is 2x minus 3. Then, using this general equation, pwede nating ma-solve yung next guess. So, what we will do is we will construct a table na mayroong isang column for f of x and isang column for f prime of x. Okay? Kasi alam naman na natin na ito is just yung sabihin yung next guess, the next guess is equal to the first column minus second column over the third column. Tama ba? So, if we label this as 1, 2, 3, so yung next guess is equal to 1 minus column 2 over column 3. Okay? So, ganoon lang siya. Initial guess natin ay 1. Ito yung f of 1, f prime of 1. Then, if we use this, ang solve natin next guess ay 0. Then, we solve again f of 0 and f prime of 0. Then, we solve for these this case ay absolute error pa din. So, this is just absolute value of 0 minus 1. So, ito yun. And since masyado pang malaki yan, so, we use ito again, 0 minus 1 over negative 3 as our next guess. Then, we continue and continue. Kung mapansin mo, ang bilis niyang mag-converge. Dito, sobrang liit na ng error. And we will see na yung solution converges to the smaller root after 5 iterations lang. So, yun. Ganun lang gawin si Newton-Rhapson. So, sir, paano yung isa pang root? We can just, since wala ka ng ibang transformation na pwedeng gawin, katulad ni fixed point, pwede kang gumamit na lang ng ibang initial guess. So, ganun lang siya ka-simple. Si secant method is naggaling din kay Newton-Rhapson method. Pero, nanggaling siya sa concept na paano kung mahirap i-differentiate si f of x such that hindi ako makakakuha ng expression ng ganun kadali for f prime of x. So, ang ginawa ng secant method is gumamit siya ng difference quotient to approximate f prime of x. So, to approximate f prime of x, gumamit siya ng parang, y sub n minus y sub n minus 1 over x sub n minus x sub n. So, equation of a slope pa din to. Formula for the slope pa rin ito. Okay? Yun nga lang, kung mapansin mo, since ganito na yung secant method, so secant na siya, hindi siya tangent, kasi nga, we are approximating a tangent line. Kung mapansin mo, hindi na enough yung hindi na enough na yung previous guess lang yung gamitin mo to arrive at the improved guess. Kailangan mo na ng dalawang previous guesses. So, to solve for x sub n plus 1, bukod sa kailangan mo si x sub n, kailangan mo na rin si x sub n minus 1. Kasi nga, ganun yung pinanggalingan ng formula from the difference quotient, yung pang-solve nung slope nung secant line. Okay? So, dahil doon, hindi din enough na yung initial guess natin ay isa. Okay? So, ganun yung mangyayari. So, secant method, yan. Similar lang din siya kay Newton-Rhapson. Yun nga lang without the evaluation of derivatives. And tulad na sabi ko sa previous slide, dalawa na yung initial guess na kailangan natin. Okay? So, yan. So, secant line. Again, ito yung dalawa. Ito na yung bago. So, hanggang sa ma-approach nyo yung point na to. Okay. So, using a different equation, let's say, x minus 2 sine x. Although, pwede mo namang mahanap yung derivative niyan, pero try natin i-apply si secant method dyan. Now, we have two initial guesses this time, 2 and 1.9. Okay? Now, take note pala, pag resolve kayo, yan, so, use radians for equations involving trigonometric functions. Okay? Kasi sin x yan. So, nas x ito. So, yung x, para maging consistent ito dito, dapat radians yung gamit mo dito. Okay? Okay. So, here we have xn minus 1, which is we assign the x sub 0 na 2. Then we have x sub n, we assign 1.9. Then ito, pwede mo naman itong ma-solve, madali lang. Ito, pwede mo naman itong ma-solve, madali lang din. So, essentially, so you have column 1, 2, 3, and 4. Pwede mong ma-solve yung next iteration as, ano ba yun? 3 minus 4 minus 2 over 3 minus 1. Yan. Tama, di ba? Ayun. Ay, baliktad pala, sorry. So, kulang pa pala ako. So, ang tama ay 3 minus 1 over 4 minus 2 times f of x, which is 4. Ayan. So, tama na. Okay? Now, take note, dun sa first iteration pa lang, makakasolve na tayo ng error. Yan, since may difference na si xn and si xn minus 1. And then, for the rest of the iterations, yung epsilon is, or yung relative error is just computed as column 3 minus column 1. So, iba siya doon sa previous methods natin. So, for secant method, yung error is computed using the values at the same row. Yeah, the same row. So, yung xn minus 1, absolute value. Okay? And ito, mabilis mag-converge. 4 iterations lang nakapag-arrive na tayo sa root. Okay? And that's all for open domain methods. And for the last content of this module, we will be discussing about closed domain methods.